Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video. And today's video is about another interesting subject, robotics, computational motion planning. We're going to see a lot of videos in this particular subject, and this is the introduction video about this particular subject. And in this video, we are going to see what is the importance of this particular subject, syllabus discussion, and we're going to give a basic introduction about this particular subject. Okay, and before starting with, I would like to set you a clear expectation that this particular subject does not deal with the design of robot or the different types of robot or something like that. Okay, this is completely depends upon the motion planning of robot. Okay, how the robot moves, that is what we are going to see in this particular subject, right? How it moves, how it detects the obstacle, after detecting the obstacle, how it can move, how to design an algorithm, how to design a planner for that particular robot. That is what we are going to see. Okay, and why is that we want to study this particular subject, right? What is the importance of this particular subject, right? Like if you take 10 years back, like, or even 5 to 6 years back, robotics will be a very interesting and very new topic, like maybe 10 or 20, 10 years back. Okay, and but right now, if you get into any particular places, like even if you take any particular cities, Chennai or any metropolitan cities, definitely there are a lot of commercial robots which is available in the market, right? You can go ahead and purchase any particular robot. It can be a small robot, a moving robot, or a moving arm, something like that. Even finally, students right now using robotic arms for their projects, right? So designing a robot is no more a challenging one. Okay, but to make a complete robot that function without any problem, that is to make a robot to move in a very free manner, even if there is many obstacles, that is a great challenging task. Okay, and that is what we are going to study in this particular subject. Okay, so this subject will be very interesting. Okay, so let me start with importance of robotics, computational motion planning. Okay, எதுக்காக இந்த subject படிக்கணும், right? So first thing, in this particular subject, being you may be a software engineer, a CSE department student, or even an electronic communication department student. Okay, this subject is applicable for both of you, and it will be very helpful for you. Okay, right? Like the main objective of the subject is to know about the motion of the robot. Like how is that we can plan the motion of the robot. Okay, so for that we will see about a lot of algorithms, how to design that particular algorithm, what are the configurations, how the navigation takes place. That is what you're going to study. Okay, so by end of this particular subject, you will have immense knowledge about bug algorithm, configuration space, and you will know about potential functions, sampling algorithms, filtering techniques, and trajectory, the motion, how it moves, right? Everything you will study in this particular subject. Okay, and that is why you are studying this particular subject. Okay, only for this 5 points you are studying this particular subject. Okay, we will start with syllabus discussion. In syllabus discussion, in first unit, you will just give the overview of motion planning. What is that? What exactly happens? Why is that we have to plan for motion planning? Like that is what you're going to see in unit 1. And unit 2, you will study in depth about potential function and planning techniques. And unit 3, you will see about various algorithms and connection strategies. And unit 4 is all about filtering techniques and mapping locations, right? And unit 5, you will study about the complete trajectory planning of a robot. Okay, so this is the overall syllabus for this particular subject. Okay, and now I'll just give you a basic introduction about motion planning. Okay, so in mathematics, there is one particular problem which is called as piano movers problem. Okay, which is a mathematical problem of a configuration of a space, right? If you want to detect the properties of a space, a configuration of a space, that particular problem, there is some problem with that configuration in particular space. Okay, that particular problem is called piano movers problem. Okay, that is a general problem. Whenever if you want to configure something in space, we have to know the properties of that particular, the characteristics of that particular area or particular space. That particular problem is called piano movers problem. Okay, and motion planning has evolved in such a way that that particular piano problem have lot of variations in that. Okay, and now the motion planning is been applied in almost all the fields. Okay, you can see animation of digital characters. Right now you have in entertainment, you can see in a lot of movies, you can see a lot of animations, real-time applications. Like you can see the animations will be very realistic, right? And even if you can see the games, right? In games you have a lot of cartoon characters that's moving very fast and very freely. You can understand it will be very realistic, right? It's all because of motion planning techniques. And it can be also used in surgical planning for industry layouts, like for verification of industry layouts, mapping and unexplored environments like new environments, and navigation to those environments, and even in drug designs in pharmaceutical industries. Okay, that plays a very vital role. Like these are the main applications of motion planning. Okay, so இதெல்லாம் வந்து நீங்க பார்க்கும்போது you will not understand. I'll just give you some examples for that. Okay, so the first one is why motion planning is very important. Okay, motion planning for robot is very important, because if you see this particular diagram, you can able to understand. This is a normal a robotic painting system which is used in many industries. Okay, this is an ABB robot painting system. Okay, now if you see this particular system, the main objective of this particular system is to paint this overall surface, right? If you take this particular surface, right, it has to cover the entire surface. Okay, so now why motion planning is very important? எதுக்காக motion planning ரொம்ப important அப்படினு பாத்தீங்க அப்படினா, we already know this particular robot arm is capable of moving here and there, right? It can move throughout the entire surface. Okay, motion planning is important because it should not leave any particular space or any dimension in this particular entire space. Okay, even this particular point, right? Even at this particular point, it should not leave any particular point in the space. It has to cover the entire surface, right? That is the main objective. And then the uniform painting is very important. Okay, it cannot give more painting this side and less painting at the other side. Okay, it has to be even painting. The coating of painting has to be even. Okay, and this can be done only by proper planar. Planar is something like an algorithm, right? We got to design an algorithm in such a way that this arm move exactly in such a way that it covers the entire surface, and it covers with the paint, it sprays the paint uniformly throughout the surface. Okay, and that is why motion planning is very important. Okay, and there are a lot of robots which has been designed right now. A lot of things is available in market. Okay, and this is another robot which is called as melon snake robot, like which is used to rescue operation, right? It can easily move to any particular area, and it can able to find out anyone is hidden like a network or something like that. You can use this particular rescue robot. Okay, and this is for drug design. You may wonder how motion planning can work in drug design. Yes, drug design plays a vital role because for example, if you take protein has its own molecule articulated linkage. Okay, it has a particular design, and by motion planning the researcher can able to understand the movement of a protein molecules. Okay, and then again you can able to understand how it folds, or the folding operation, how it works. So if they can able to design a drug, right, and if they can able to combine the drug with the protein molecules, they can understand how it works. It can help in creating a lot of pharmaceutical drugs to overcome many diseases. Okay, so that is possible with motion planning. Okay, so these are just an examples to understand why motion planning is very important. Okay, and as I said before, piano movers problem is the mathematical problem. It's a mathematical problem, a general problem which is in mathematics, like to configure any particular space. Okay, it is a problem to configure or to understand the properties of a space. Okay, but that particular problem has been found lot of variations right now because of motion planning. Okay, and I'll let you know what is that. Okay, first one is offline planning. Offline planning na enna appdin pathinga appadina, consider a particular robot. Okay, இது வந்து robot, இது வந்து ஒரு polyhedron. Okay, a rigid body. Understand one particular thing. This is rigid body. Okay, I'm just explaining what is offline planning in the such a way that, and what is the piano movers problem, right? So this is a rigid body where you don't have any connectivities here. Okay, if this is a rigid body, right, and if this rigid body is trying to move from here, this particular place to this particular place, okay, and if there is lot of obstacles like this, fixed obstacles, fixed obstacles. Okay, now this particular rigid body, the polyhedron, has to move in such a way that it should not collide with these obstacles, and it has to reach this particular place. Okay, and now you understand the problem of this particular rigid body to overcome these obstacles. That is called piano movers problem. It is a common problem. The only problem it has right now is it should not meet this obstacle, right? It should not drag with this obstacle, and it reach this particular place. Okay, and what is offline planning here? Okay, so this is the very old problem, right? The only thing is it has to move to that particular place. That's all. There is no other conditions for it. So if there is any obstacle, it has to overcome that and it has to reach. Right? That is the only thing that is called piano movers problem. And what is offline planning in the sense? If this obstacles is already known, if the obstacles already known, முன்னாடி தெரிஞ்சிருந்துச்சு அப்படினு பாத்தீங்கன்னா இந்த ரோபோட் எப்படி டிசைன் பண்ணிருப்பாங்க அப்படினு பாத்தீங்கன்னா, this design can be done in such a way that it can directly go this way, take a right and go straight to this particular obstacle, or it can go this way, take a left and go this way, right? Because the obstacle is already known. It is a fixed obstacle. Okay, so the execution can be already fed into it, and so that it can reach the particular destination without any problem. Okay, this planning which has already been executed, right? So this is called offline planning. எதுமே ஆன்லைன்ல பண்ணாம ஆன் ஸ்பாட்ல பண்ணாம ஏற்கனவே டிசைன் பண்ணி வச்சு பண்ணோம் அப்படினா, that is called as offline planning. Okay, so this is for a rigid body, a common problem, that is piano movers problem. But right now, because of emerge of robots, right, we have lot of other variations of this problem. Okay, that is not only fixed obstacles. Okay, the first variation of this problem is sofa movers problem. அப்படினு என்ன சார் sofa movers problem na என்ன அப்படினு பாத்தீங்க அப்படினா, இந்த rigid body எடுத்துக்கோங்க, fixed obstacle இல்லாம ஒரு planar obstacle. If the object moves in a planar obstacle. What is planar obstacle? Like a graph. Okay, like a graph. Like a graph. If the robot has to move from here to here, right? This is the source and this is the source and this is the destination, and all these points are obstacles. All these points are obstacles. This is called planar obstacles. If the object moves from here to here in a planar obstacles, right, then this particular problem is called sofa movers problem, right? And there is another problem which is called as generalized movers problem, which is nothing but right now there are lot of robots. If you take robot, it can be a mobile robot or a small moving robot or even a robotic arm which moves here and there, right? So generalized movers problem in the sense, instead of this rigid body, there can be a robot with a lot of joints, right? Example, you know, Chitti Robo, right? It has arms, legs and everything, right? Everything is interconnected. And you can see that in that movie, like you would have seen, like it will be dismantled and it will be again assembled and all those things, right? So if there is lot of joints, that particular robot will have a different problem, right? So that is called a generalized movers problem. Okay, and a whole, what is very very important is the robot should not collide with any obstacle, right? So how is that can happen, right? அது எப்படி பண்ண முடியும்? எப்படி வந்து ஒரு obstacle ல இது பண்ணாம டிராக் பண்ணாம இல்ல மோதாம வந்து டிசைன் பண்ண முடியும் அப்படின்னு பாத்தீங்க அப்படின்னா, in order to do a proper design, then each and every point in the robot, for example, if this is the robot, right, any point of this particular robot should not collide with any obstacle, right? So what has to be done? Each and every point of the robot has to be represented, right? It has to be configured properly, right? இப்போ இங்க எடுத்துட்டீங்க அப்படின்னா இந்த எல்லா பாயிண்ட்ஸ்மே வந்து பாத்தீங்க அப்படின்னா ரெப்ரசென்ட் பண்ண தெரிஞ்சிருக்கணும், ரைட்? ரெப்ரசென்ட் பண்ண முடியணும் அந்த ரோபோட்ல, ரைட்? சோ தட் இந்த பர்టిక్యులர் பாயிண்ட் இடிக்காம இருக்கணும்னா அதை மட்டும் கன்ஃபிகர் பண்ணலாம், ரைட்? இதை மட்டும் இடிக்காம இருக்கணும்னா அங்க கன்ஃபிகர் பண்ணலாம், ரைட்டா? So what is configuration? Is representation of the points, representation of all the areas in the robot. That is called as configuration, right? And what is configuration space? All the configuration that a robot can achieve, right? என்ன configurationலாம் அந்த ரோபோட்டை நம்ம பண்ண முடியுமோ அது எல்லாமே என்ன சொல்றோம் அப்படின்னா configuration space அப்படின்னு சொல்றோம், right? And there is something called degree of freedom, DOF, degree of freedom. Degree of freedom என்ன சார் அப்படின்னு பாத்தீங்க அப்படின்னா, இப்போ முன்னாடி இனிஷியலா பார்த்தோம் அப்படின்னா ரோபோட் மூவ் ஆவறதே பெரிய விஷயமா இருந்துச்சு, ரைட்டா? ரோபோட் ஒரு இடத்துல இருந்து அந்த இடத்துக்கு ஆட்டோமேட்டிக்கா மூவ் ஆகணும், அதுதான் பெரிய டாஸ்கா இருந்துச்சு, ரைட்? பட் ரைட் நவ யூ ஹேவ் லாட் ஆஃப் வேரியேஷன்ஸ் ஃபார் தட், right? Lot of accuracy is very important, right? Like not only moving is important, it has to move in a particular direction, in a particular geometry, in a particular angle, right? In a particular distance, right? All these are very important. அப்போ மூவ் பண்றது மட்டும் பெரிய விஷயம் இல்ல, ஆங்கிள் என்ன, டைரக்ஷன் என்ன, அதோட ஜியோமெட்ரி என்ன, ரைட்? அதோட லொகலைசேஷன் என்ன, இது எல்லாமே முக்கியம். இது எல்லாமே டிஃபரண்ட் பாராமீட்டர்ஸ், ஓகே? டிஃபரண்ட் வேரியபிள்ஸ், ஓகே? இது எல்லாத்தையுமே தான் என்ன சொல்றோம் அப்படின்னு பாத்தீங்கன்னா டிகிரி ஆஃப் ஃப்ரீடம் அப்படின்னு சொல்றோம், okay? And any particular robot, right, if it has more degree of freedom, நிறைய degree of freedom, நிறைய parameters இருக்கு அப்படின்னா that is called as redundant robot. That robot will be a redundant robot. It is called as redundant robot. And if there is extra, இன்னும் அதிகமா இருக்கு, degree of freedom is extra more than the one which is redundant bit, then it is called hyper redundant robot, okay? I repeat it, if there is more degree of freedom, that is called redundant robot. And if there is even more, like even extra degree of freedom, that is called as hyper redundant robots, okay? This is basics about piano movers problem.
Thank you students, thank you for watching. கண்டிப்பாக இந்த வீடியோ உங்களுக்கு எல்லாருக்கும் ரொம்ப யூஸ்ஃபுல்லாக இருக்கும் நம்புகிறேன். Subscribe Passionate Professor and keep learning. Thank you very much.